Assalamualaikum warahmatullahi wabarakatuh. My name is Amin Muklis Berazali. My metric number is AE150028. Today I will be explaining the introduction part of our project, which is solar tracking device. So I will start with the solar power energy. Solar power energy is one of the renewable energy. This energy convert heat to electrical energy. Okay, so this is the picture of Elon Musk. He is the CEO of the Tesla company, the company that is famous for um, building many projects that use the renewable energy. So this company recently released solar roof tiles in order to maximize the solar power usage, reduce environment pollution, and decrease the dependence on non-renewable energy. So the hypothesis of the solar panel or the solar roof tiles is uh, the more sunlight projected to the solar panel, the more the energy harvested by the panel. So our group will build a solar tracking device made up of solar panel, light dependent resistor, motor, and the microcontroller PIC 16F77A. So the function of our project is the LDR will detect the most sunlight, and the motor will rotate the panel to the sunlight. Okay, so this part will be explained by my other fellow members uh, more briefly. Okay, that's all. Thank you.
Hi, I'm Wong Kah Ken, and now I'm present the objective of our project. Our objective is to design and develop a system to harvest sustainable energy effectively, and we also need to cooperate in group and solve the problem arise during the project. We have to apply knowledge learned in class on the project and produce a good piece of work. Now, this is the methodology of our project. As we can see on the right hand side is the flowchart for the operation of the solar tracking system. First of all, the LDR will sensing the light intensity, and value from LDR will transfer to the PIC controller. So by this method, we will sensing the value of LDR. If the value is low, we will turn the rotor by 10 degree, but if the value is high, it will stay static.
My name is Muhammad Nazrul bin Muhammad, and I will present about the item we bought and the item that we need, and I also will show the item that we have put it on the breadboard. Okay, the first item is of course PIC 16F877A, photoresistor LDR, DC motor, solar panel, TFT LCD, and MISC. Okay, then I will show you the circuit that we have made it. Here is the motor, the solar panel, and the IC, and all the item is in the on the breadboard as shown here. Okay, that's all from me. Thank you.
So in this project, we are using Proteus 8 to simulate our circuit. So after putting all the components in the as given in the schematic, we put the generated hex file from the MICROP program, and we hook it up in the PIC, and then we start our simulation. As you can see, when our LDR1 and LDR2, they both have the same reading, our stepper motor will stay stagnant as addresses in our program. So when we increase the LDR2, we will rotate to 45 degree and 90 degree and search for the optimum angle to absorb the largest amount of sunlight. So when we increase the reading of LDR2, so we can see that in a while we can see that it will rotate to 45 degree. So in case that when the LDR1 has a larger reading, we can see that it will rotate to negative 45 degree in a while. Yeah, you see. So this means that when LDR1 has a higher reading, the solar panel will turn to the direction which is nearer to LDR1, and when the LDR2 has the higher reading, will turns to the direction of LDR2. Thank you. My name is Lim Xiang Yang. In this group, my task is assigned as code writing and circuit simulation. So first I would like to say that we write the code in a program called MICROP, and since using the Windows 10 default recording player, I can't get the MICROP to get on recording. So I copy all the code and paste it in the notepad. So this is the code for our project, the solar tracking system. So at first we initialize the light and light 1. Light and light 1 is to measure the reading of the LDR. So we write a read function for the LDR. So if the light surpasses the value of 60, it will give a reading of 0, else it will give a reading of 1. So since we are using two LDR in our project, hence we have two read LDR function in our project. After that, we also write the compare function. So if the LDR1 is the reading of LDR1 is smaller than LDR, it will rotate to the direction of, it will started the stepper motor. After that, it will rotate the stepper motor to the direction of 45 degree, then delay by 500 millisecond, and after that it will turn to 90 degree, and then it will come back to 45 degree and come back to 0 degree positions. So this is the case for if the LDR reading light 1 is lower than light, or else we will rotate when the LDR1 is bigger than light. The LDR, it will rotate negative 45 degree, negative 90 degree. So in turns, this means that the stepper motor will rotate in 180 degree. So because when the LDR reading is similar, it means that the position is suitable for the solar panel, is the best position for the solar panel to absorb the sunlight. So we also write if the LDR1 is equal to LDR in reading, the angle that the stepper motor turn will also be the same, and it will delay by 1 second to test it out again. So in our main program, we initialize the port B and we use while loop to read the reading of LDR1 and LDR2, and then we use the compare function which just now I have just explained.